will see various types of experimental design. Experiment is a method and there are variety of designs available to any experimenter. If we know them as per our needs, we can employ various designs. While planning and selecting a design, we must also know which is the best possible in the circumstances. There are 4 types of experimental designs. Pre-experimental design, true experimental design, factorial design and quasi-experimental design. Can you guess from these titles which is the best one? It's giving away, the meaning. True experiment must be the best. Pre-experiments are before you achieve the experimental step, you are doing something, cannot be called as experiment, you are doing something which is pre-experiment. But we will see that we should not be taking stock immediately before we go in. But I am just asking from the titles itself if you can see. And time series design is also called, comes under quasi-experimental design. Let's see the first one, pre-experimental design. What does it say? Single group post-phase design. Now we will see how the terminology is used. You have also seen there, T stands for treatment, isn't it? So you must use the same terminology here throughout the experimental design. Single group post-phase design. What does it mean? There are no 2 groups. Experimental control is not there. There is only one group, that is single group. And post-test, that means we have not given them pre-test. We have taken a group on it and we have just found a variance. So that is called single group post-test design. Treatment and post-test. Post-test scores are shown by T1 and T2. T1 is pre, T2 is, and treatment T is shown by capital X. Now, how would you rate this? What control? Now you see the threads. Internal validity thread, external validity thread. What we said there? We have to randomly select both the groups. Basically, there are no 2 groups, only one group. So how you can compare? Isn't it? There is nothing to compare. So there is no control on extraneous or situational variables at all. Same group, one teacher is teaching, whatever treatment you are giving to the same group. Now, single group, pre-test, post-test design. Little improvement. Group is only one, but you test them before, then you give them the treatment, and then you test them again, so that how you will find whether your treatment is effective. You see the difference between pre-test and post-test. If there is increase, you will say it is because of your treatment. Can you really say that? It is because of your treatment. In pre-test, average score is 45. Then you give them the treatment and then you give them the post-test, the score is 60. So you say that there is an increase of 15 scores and it is because of the treatment. Am I right in saying that? You have not controlled many variables. Say in between, some other, say Professor Jayan Narikar had come and he addressed it. Or Sunita Williams had come. Maybe they got inspired to learn science. Isn't it? And it's not because of your treatment, it is because of visit of Dr. Sunita Williams. If there was a comparison, so both the groups get Sunita Williams lecture. Suddenly Dr. Sunita Williams came from NASA and she visited your school and she met the students and they inspired them something happened because you had not planned that. So your dependent variable is at rate. The result what you are showing, 15 scores are increased, need not be only because of your treatment. Then the third design. Two groups, static design. What are these? One is experimental group and other is control group. Experimental group always gets a treatment and control group does not get a treatment. But it is only post-test, static. So you are not giving pre-test to both the groups. You select two groups. How you select? I am not said randomly, right? As you like. They are not selected randomly. That's why it is called pre-experimental design. You take any two classes. The one you like, you teach them experimental. One you don't like, put them into control. Anything can happen because you have not randomly selected them. Nowhere it is said that they are randomly selected. And treatment is given and note. Post-test will tell you there is a difference. But there are situations where you cannot always say that I want to randomly select. You can't do that. Whatever you get, because all the time you don't have a control on the subject. So, but in that case, you have to conduct an experiment, you conduct an experiment. That's why it is called pre-experiment. This is not done randomly. In experiment, it is always randomness which is important. Second is true experimental design. See what is written there? Two groups, randomized subjects, post-test only design. This word itself is very important. It makes the experiment true experiment. There are groups and you have no bias. You are putting students into experimental and control group randomly. Random selection. Anybody can be in the experimental group, anybody can be in the control. And that's why you have every control over the subject. But it is only post-test. Second type is two groups, randomized match subjects. One step ahead. They are randomly put, but as I said earlier, both of them have 60 marks. Now randomly you are putting them. One goes here, another goes here. So they are randomly put into two groups, but they are also matched. So it is much better experimental design. The third is two groups, randomized, pre-test, post-test design. In the first two, there is no pre-test and third is post-test. And randomized Solomon three groups design. Randomized